All right. So I want to, before I talk about power sets, I want to talk about a few things here. So let try to understand this concept of inclusion and so on and so forth. So let's say I have set U, which is basically collection of 1, 2, 3, 4. So there are these numbers which are set of elements of this. And then I have, along with that, I have 1, 2, 3. This is also one element of it. And then I have 4, 5, also as one element of it. Okay. So this is set. Yeah. What are the objects of this set? There are some numbers which are these objects. And also there is 1, 2, 3 as a set also there. Yeah. And then there is also another set 4, 5, which is inside that set. Okay. Now let's ask few questions. So let's take this to be my set. So U, and then let me take my set A to be 1, 2, 3. Question: is A a subset of B? And then that's question one. Sorry, A subset of U. Question one. Question two: does A belongs to U? Question three: is A as a set subset of U? And if A as a set belongs to U. Okay, let's try to understand all this. What does it mean? Huh? So question one: is A a subset of U? Yeah. Why? What are the elements of A? Number one, number two, number three. Are they elements of your set U? And the answer is yes. So this is correct. Does that make sense? Yeah. Because every element of A is an element of U. Is your set A an element of set U? So A is 1, 2, 3, and you have this element here, isn't it? This is the element of your set U, right? Isn't 1, 2, 3 also an element of your set U? This is one object, right? Is it inside the U? Yes, it is. So this is also true. Okay. Now let's look at the next one. Is set A, so a set. So what is the meaning of this? It is a set which contains what inside it? It contains A inside it. So it contains a set inside it. So this is going to be 1, 2, 3. Does it make sense? Yeah. That is what is the meaning of the. So A is a set, and curly bracket A means what? We have a set whose member is this A. What is that A? That is also a set. So question, is this a subset of you? Right? Why? Because of this element. Precisely because of that element. Okay. Now let's look at A. Does set A belongs to you? So do we have this thing? Does this belongs to you? It does not. Right? Yeah. So this guy does not belongs to you. Because why? What belongs to you is this unit, this unit, this unit, this unit, this unit, this, and this unit. Yeah. So you see that this element is not here. Okay. So that is the difference between. Is that making sense? No. Yes, go ahead. Look at the variation of this problem. Suppose, let me modify this problem to illustrate your idea. Suppose I have example. Suppose I have U to be a collection of. So U is a set universe. This contains of two sets, 1, 2, 3 as one element, and then I have 4, 5. Okay. Now the question is A a subset of U? What is my, sorry, U, that's right. Where, what is my U? My A is 1, 2, 3. Yeah, I mean, this problem is different than the previous one, right? So is this a subset of this? And the answer is no. Why is that? What is the definition of subset? If X belongs to A, implies X belongs to what? U, right? That is what the meaning of the subset is. Let's take X belongs to A. Let's take 1. 1 is not here. Yeah. Does that make sense? Number 1 is not here. There is a set which contains 1, 2, 3, but 1 on its own is not here. Therefore, just by looking at that, I can say, well, that this is not a subset of U. Make sense, right? Okay, so clearly A is not a subset of. Then the question is, does A belongs to U though? Yes, still belongs to you, right? Because set, now we are asking, oh, this set 1, 2, 3 as a set, is it so this element, this is an element of this here, okay, because of this statement. All right, let's investigate a little bit further. Question, does empty set belongs to you? Yes, so empty set is a subset of all sets. Yeah, sorry, empty set, oh sorry, this is a good question. Does empty set belong to you? Anyone? The answer is no. Empty set does not belongs to you. Empty set is a subset of you. That's right. Does it make sense? There's a difference, right? Empty set is not an element of you, but empty set is a subset of every set. Okay? Yeah. Does that make sense? Right. Yeah. So these are the distinctions. So you have to look at the brackets carefully and see what are the elements, right? Elements, some of these elements. So if you look at this again, if you investigate this, some of the elements are numbers, some of the elements are sets. Okay. So anyway, so now next concept, which is a very interesting concept, is the concept of power set. So what is a power set? So let's first work out an example of a power set. So let's take set A, 3, 1, 2, 3. Okay. And we want to basically take power set of it. So what is a power set? So power set is a set whose elements are all the subsets of A. So power set of A. So this is a notation for power set of A. Yeah, it is collection of all the possible subsets of A. Okay, let's see. What are all such possibilities? So let's list it down. So first of all singletons are the subsets, right? Do you agree? Do you agree with that, right? These are all subsets, no? Do you agree that 1 is a subset of A, right? 2 is a subset of A. 3 is also a subset of A, right? So these are all the set of size what? 1. Okay. Now, what are all the sets of set of size 2? Anyone? 1, 2, then 2, 3, 1, 3, and that's all. Do you agree? 1, 2, 2, 3, and 1, 3. Now let's go for all the set of size 3. 1, 2, 3. There's exactly one set. Do you agree? Yeah. Makes sense, huh? Yeah. And then there is one more set which is not here, which is what? Empty set. So empty set is a subset of all sets, right? So what is the size of P of A in this case? So cardinality of A here is basically 3. We are trying to investigate, is there any relationship between the size of the power set and the. So what is the size of the power set? Let's count it here. 8. Do you agree? So empty set 1, 2, 3. So all 3, 4 there. 5, 6, 7, 8. So empty set has basically 8 elements in it. What is the relationship between 2 and 8? I mean, if I just give you 2 points, you can create many relationships. But the idea is the relationship is the following: 2 to the power 3. Yeah. So here is a result which we can prove very quickly if you want. Let's basically prove this. All right. So if the theorem or result, whatever you want to call it,